the two quantities by division. In other words, fraction. Someone give me a fraction.
2/3.
That wasn't really short. We're gonna miss everything if you go. The notes are really short. It can also be written as this. 2:3. So the top number goes in the front, the bottom number goes in the back. You write it as a colon.
It's on the back of the cover, so.
Yeah. Sorry about that. That's an example of a ratio. A proportion is just two fractions or two ratios that equal each other. Might look something like this. X over 5 is equal to 6 over 7.
What?
Proportion is just two fractions that equal each other, and you generally solve them. A ratio is just a fraction.
They don't equal each other.
You would solve to figure out what value to make.
Oh, you do the cross multiply and divide.
What is that in a second? You go right. In this first example, we're going to work on setting up ratios. It says Mr. Hunt knocks down 85 out of 100 free throws while playing basketball. Okay. Find the made to attempt ratio for Mr. Hunt as a simplified fraction. Well, whatever comes first. So the first thing is make. How many shots did he make? How many shots did he make?
85.
85. That's going to go in the top. Right? Whatever comes first goes in the top. Whatever comes second goes in the bottom. So how many shots did he attempt? 100. What does 85 over 100 simplify down to? 17 over 20. Always, always, always simplify. Simplify your fractions. Always.
That says 6 over 7, right?
Yes, for the proportion.
Yes. Okay. If we look at B, I think there's some space for you to write. It says find the make to miss ratio for Mr. Hunt as a simplified fraction. Well, again, make was first, so how many shots did he make? 85. That's going to go on the top. Miss is second. Well, if he made 85 out of 100, how many did he miss? Yeah, how'd you get there? Yeah. He's had a total of 100 shots. 85 of them are makes. That means 15 of them have to be misses. To figure that out, just do the total minus how many he made, and that gives you how many he missed, which is 15. Again, always, always, always simplify your fractions. What do we get? 17 over.
One thing I'll say about this is, I told you from day one, you need a calculator. That's fine if you borrow ours, we understand that. But we have 10 spots over here, and we had to go get more calculators. So that means about 13 people here aren't using a calculator. That's not good, because we know when you're going home, you're not using it. It's not practicing it. It's very hard when you're trying to reduce fractions with this calculator. It's not going to do it. It's an improper fraction. That's how we need it. It's going to do it as a mixed number. You're not going to be able to solve it. So when you borrow our calculator, it's not going to give you the right answer. We're trying to tell you that. Unless you understand how they work, how to reduce it by dividing by a common number, that's the way to do it. But you guys don't know that. Get your own calculator. You are going to need it for Algebra 2. So might as well get it now, not wait.
Get your use out of it while you can. Okay? Questions over that?
All right, let's look at number 2. In a triangle, the ratio of the three sides are 4, 6, 9. Its perimeter is 380. Find the measures of each side of the triangle. Now, this is talking about ratios. This is not saying that the sides are 4 units or 4 inches, 6 inches, 9 inches. It's saying that's the ratio. That means they are being multiplied by some number. We don't know what that number is. We're trying to figure out what it is. I talk about Hot Wheels cars. You guys know about Hot Wheels cars? Someone seen Hot Wheels, Matchbox, something like that? All right, that car is 1/24th the size of a real car. Meaning if I blow it up 124 times what it is, it would be a real size car. All right. That's the same thing. We got to find that number. In that case, it was 124. We got to figure out what number multiplied by each of these numbers would make this to be the full size of the 380. So how do we do that? Well, the nice thing is ratios means they're all being multiplied by that same number. I don't know what that number is, so I'm going to call it, let's say, x if I don't know what it is.
Okay.
So call whatever you want, but I'm using x right here. So what I'm going to do is this. I know 4 times this number, so 4x, plus 6 times that number, plus 9 times that number, would give me the total distance around. In this case, what is the total distance around this triangle? 380. 380. Now we're going to go ahead and solve. Every time we've been setting up equations lately, it looks really long. It's like, man, I don't know what to do here. But we know that our next step is always going to be
Add all of them.
combining like terms. Very good. So 4 plus 6,
10 plus 9.
10 plus 9 gives me a
19.
19x is equal to 380. Last step, divide by 19, divide by 19. X is equal to 20. So good. We're done?
Yep.
Yeah.
No.
Nope.
Oh, plug it in.
Plug it in. Does it say find X?
Find the measures of the sides of the
Find the measures of the sides.
triangle.
Well, it's a triangle, yes. How do I find the measure of each of those sides?
Plug in. X.
I'm going to, everywhere I see an X, I'm going to plug it in. So each of these represents a side. So I'm going to take those numbers and plug it in. So the first one, 4 times that number gives me a 4 times that number gives me 4 times that number, 80. There's one side. 6 times that number, 120. The last one, 9 times that number, 180. Okay, those are the sides of the triangle. Mr. Gar speaking. Hi. Yes. No problem.
Yep.
Bye.
I'll go without you.
There's stuff. Check it out.
Let me go.
So right there, there's my 3 sides. Now, what if it asked? This is a side question, but what if it said angles? What if it said I want to find the ratio of the angles? What would it be set equal to instead? 180. It's a very common question. You'll see a lot. Remember, sides are equal to usually a different number. Angles are always equal to 180. So make sure you know whether it's talking about sides or angles. All right. Doing that? Questions with that? Now, this next one is 1. I'll say this. As far as the steps, it's really not that hard. But this is going to be 1. If you can solve this next one, you can solve any problem in geometry you'll see the rest of the year. This is one of the longest, most involved problems, but we're going to do more and more of these so they get a lot easier and a lot quicker. You have a problem that looks like this. Solve the proportion. Kanaj already hit on it a little bit there, saying, how do I solve proportions? How do I go about solving this problem? What do I do? What are you saying, Liz? Cross multiply is correct. And we know cross multiply goes on here. Take this number, multiply it there. I know I cross multiply when I have that equal sign in between there. So I'm going to cross multiply those together. Well, I'll do the first one for you because I'm a nice guy. 1 times 7 is a 7. Good for you guys. Now you got to figure out the other side.
You can do that. You did the first one.
I did the first one. You guys have to do the other one. Now, I will help you out a little bit here. Well, I can't do this in my head. I'm not going to do x plus 5 times x minus 1. I'm not going to be able to write that off. I know it's not going to be 7. But here's something helpful hint that I will tell you guys. Anytime you see this, where it's got a binomial, trinomial, what it is, something other than one number, get in the habit of putting these in parentheses. This is going to help you in a second organize this. So I put that in parentheses, and now I'm going to cross multiply. And I'll show you why that matters here in a second. You don't have to, but it will help you keep things organized. So really, just like before I did 1 times 7, I'm going to do this times this. It really represent one term. So I'm going to say x plus 5 times x minus 1. Nice. Again, all of you have done something like this at some point in time in your mathematical careers.
Yeah.
So hopefully remember, does anyone remember what would be the next step in here? What that step is called?
Distributing.
It is a type of distributing. It is called foil. So it's a type of distributing called foil. For those of you who forget what a foil is, it has this little acronym. Just like cool people count their coins. Foil is first, outside, inside, last. Let's do exactly what it says. The firsts. So I'll rewrite this. So it's the same. So 7 is going to be over here. Not changing. Let's do the firsts. Well, the first things are there. Those are the first one, each of them. So what is x times x? Be careful. That's what a lot of people won't say.
1x.
X
to the second power.
X squared. You add the exponents when you're multiplying. So x squared. They always will be. It'll always be a squared or third power. However you want to look at it. All right, so now the next one is the outsides. What are the outside pieces in this foil? X and negative 1. What's x times negative 1? Negative 1x. Pretty easy there. Negative 1x. Now we do the I. Stands for insides. We have 5 and x. Very good, Gary. 5 and x. 5 times x gives me plus 5x. And now the lasts. The ones that are last are the 5 and the negative 1. 5 times negative 1 gives me
-5.
correct. Negative 5. Negative 5. Now, whenever you do FOIL, those middle terms are always going to combine together. There's always going to be combining like terms. Middle ones will. Either they'll get smaller or actually cancel themselves out in some scenarios. So let's go ahead and reduce it one more time, and we're almost where we need to be. So when I do so, the 7 is still over here on the left side. X squared has nothing to combine with. What is negative x plus 5x?
4x.
What do we got, Alex? There you go. We got 4x minus 5. Nice. And you've done this before. It's combined like terms. Now, there should be a little bit of a red flag going up because I can't solve this like a bear problem is what you guys would think to do. The reason I can't do this is because I have a squared term, x squared, and a term to the first power. So I can't do the bear method. If one of those is missing, go right ahead, start solving. Like a two-step, multi-step equation, start solving. Can't. So I have to do what? Already combine them. That step already combined. Nah, that's not bad guess here. What I need to do is this. Whenever I do this and I have a squared term and a term to x power, I always need to set it equal to 0. What is this equal to right now? 7. So how do I make that a 0? Subtract the 7. So minus 7. Where's the 7 going to combine with? The x squared, the x, or the 5? So negative right there. Gone. Now I have a 0 equals x squared plus 4x minus 12. And this is what we want. All of you did a lot of this. Pretend that 0 is gone. This is what a lot of you guys did last year. And what do we have to do when we have a trinomial like this? An x squared, an x, and a number without a variable, a constant. Do you remember what we have to do? Maybe include starts with f, and it's actually what we did here. We already foiled. I want to do reverse foiling. Another one starts with f. Reverse foiling. Teach me. No. Larry's first time, not the second time. Now what was it? Starts with factoring. Gotta teach me how to factor. You guys watch that video, teach me how to factor. So that's what it is. So when I have it equal to 0, I gotta factor. I gotta figure out what x is. I'm solving for x. I know that is because it's equal to 0. So let's figure out what it is. This is the one where you have to look at the last term when we're factoring. Look at that last number. I need to figure out what numbers factor or multiply together equal this number, but add to be the middle term. So I need to put the factors, and we'll do more of these so they're not going to be too confusing. Negative 12. You're going to do it. You do a lot of this in algebra too. So those are the numbers. Yes. Now I was going to show you this. And again, we'll get better at this. You'll start recognizing the numbers and the patterns. But if you don't know what they are off the bat, go through what are the factors that multiply to be 12. I'll tell you this. I like to start with the number 1. Not 1 and 2. 1 times what? 1 times what is 12? 1 times 12. 2 times what is 12? 6. 3 times what is 12? And then if I keep going on, the numbers will repeat. Once you're about 1 away, you know you're pretty good. You don't do any further than that. So those are my factors. Those are the numbers that multiply together to give me 12. Now, since it's a negative, how do I get negative numbers when I multiply? Well, one's got to be negative, one's got to be positive, right?
6 plus negative
Now, which one is it? Well, look at this middle number right here. If this middle number is positive, that means the larger number is positive. It wins out. If this was a negative, that means the larger number is negative. The more you have, it kind of wins out the battle. So I automatically know all these numbers are negative. Because when I multiply, it gives me negative 12, but it'll add together to be a positive number.
This is airplane method.
This is kind of the airplane method a little bit. Yeah, so not this one, but we'll do airplane down the road in factoring. Now, when I do this, I need to figure out what two numbers, when I combine like terms, give me a positive 4. So which one of these want to add together give me a positive 4?
2 and 6.
The negative 2 and 6. 6 minus 2 is positive 4. If I didn't know, 12 minus 1 is 11. 4 minus 3 is 1. So these are my numbers. That's important because it's going to help me factor this out. So when I do so, I'm going to put it still equals 0. I had an x squared. So now when I factor this out, I'm really going to break this into two separate parentheses. They both begin with x. What numbers go behind those x terms? Negative 2 and that positive 6. Almost there. Last year, a lot of you guys were done at that point. You factored it. Fantastic. But because it says equals 0, I want to figure out what each of those x's are. Well, how do I multiply numbers and get a 0? How's the only way to get a 0 when I'm multiplying? What is it? Times 0, right? Any number times 0 gives you a 0. So that means these are numbers. I don't know which one they are. But I know one of these numbers has to be 0. That's the only way you can get a 0. They both could be. One of them could be. But they have to be 0. So how do I help that? Use that at my advantage? Well, I'm going to set each of these equal to 0 to figure out which one it is. So the first one, I'm going to say x minus 2 is equal to 0. Install in a second. And I'm also going to say x plus 6 equals 0. Go ahead and solve. This one's going to be one stepper. Add 2, add 2. So x equals 2 in this case. The other one over here, minus 6, x equals negative 6. So those are my two answers. Now, in geometry, so there's going to be two answers. I know there's going to be two answers because this is a parabola. It's going to cross the x-axis at 2 points. Most of the time, unless it's just hitting at 1. But you usually have two answers with these. Now, here's what you got to be careful of in geometry. Remember, geometry is earth measure. What always has to be true about measurements? It has to be positive. So you have to always be careful to make sure if I plug it back in, it gives you a positive answer. Now, good thing is this isn't geometry, this is just an algebra equation here. I can have negatives, that's acceptable, that's good. So I know I'm done. And a lot of you are sitting there, you're giving up saying this is a long problem. Realistically, in the world of math, this is not that long of a problem. But to some of you guys, it's not a two-step equation like it used to be. It's a little bit more work. Now, there are some things to do to streamline this, and we'll teach you those more and more later on in the year. But I can actually be done right here at this part and say I'm done with this. Why? What do you notice about these numbers right here relative to the ones in the green? They're flipped. So whenever you find your numbers, as long as 1 is the leading coefficient on these, all you do is just take the opposite. You'll have your answers. So I could have right here, once I got to this purple part right here, I could have said, oh, all right, well, x is going to be positive 2, and x is going to be negative 6. And you know your answer right there. You don't have to go ahead and prove. Again, there's no other shortcuts we'll show you down the road as well, but that's it. That's your little crash course in factoring. Especially from this. All right? Questions on that? We'll do more. Don't worry about it. The process is the same. You do the same stuff over and over again. It's like proofs. Looks confusing early on, but you'll be done. Question?
So the answer was x equals 2 and x equals
X equals positive 2 and x equals negative 6. Correct. Those are my two answers to this one.
Me too.
Get there.